In the beginning, there was light. Everything we are and everything we know is because of light. The light of distant stars and galaxies tells us the story of the universe. And the light of one star, the sun, makes life possible on our planet. When we think of light, we most often think of the visible light we see with our eyes. Yet visible light is only a small portion of the broad spectrum of radiation that includes radio waves, infrared, ultraviolet, X-rays, and gamma rays. When white light passes through a prism, we can see that it is made up of many different colors. We see this happen naturally when water droplets in the air reflect and refract light to make rainbows. Nature creates other illusions with light. Bent by ice crystals high above the clouds, light can form halos and pillars around the sun and the moon. When refracted by heat, light forms mirages. Scattered by our atmosphere, it makes the sky blue and paints sunsets with brilliant shades of red and orange. In 1960, a new and radically different kind of light was created, the laser. The word laser is an acronym, which means each letter in laser stands for a different word. Those words are light, amplification, by stimulated emission of radiation. To understand what this means, let's see how a laser works. In a gas laser, the tube containing the gas has a totally reflective mirror at one end and a partially reflective mirror at the other. The gas is made up of countless atoms that are energized by a strong electric current. This electric current excites the atoms and results in the release of a unit of light energy, or photon. Stimulated emission occurs when a photon that has already been released passes near an atom in the electrically excited state and causes it to release another photon. This photon will be of the same frequency or color and will travel side by side with the first. These photons will bounce back and forth between the mirrors, multiplying each time. A portion of this light will pass through the partially reflective mirror and form a laser beam of coherent, amplified light. Why is laser light different from other kinds of light? Ordinary light from the sun or from a light bulb spreads out in all directions from its source. This kind of light is known as incoherent light. Laser light consists of waves of light which are in phase. That is, the waves are aligned with each other. This is called coherent light, and it is why laser light is special and unlike any other kind of light. The color and intensity of a laser beam depends on what type of laser is being used. Small lasers are used in surveying, in classroom science demonstrations, and even in planetaria and auditoriums as pointers. The power of these tiny lasers is typically measured in milliwatts or thousandths of a watt, and their energy is usually emitted as visible red light. On the other hand, carbon dioxide and certain other lasers give off the energy in the form of invisible infrared light or heat. They're also much more powerful, which is why they're used in industry for welding or cutting, and in medicine to replace metal scalpels. An added benefit in surgery is that these lasers cauterize an incision as soon as it's made, thus minimizing blood loss during the operation. The power of these lasers is measured in tens or even hundreds of watts. The most powerful laser in the world is NOVA, a 120 trillion watt giant at the Lawrence Livermore Laboratory. It's used to momentarily duplicate the heat at the very center of our sun for experiments in nuclear fusion. Nowadays, lasers are in such widespread use that you may be using laser technology without even realizing it. Tiny low-powered lasers inside compact disc players and laserdisc video players read and decode audio and video information. This also happens with home computers through the use of CD-ROM discs. Lasers are also used to scan the barcode on items at the supermarket to calculate your grocery bill and to make the three-dimensional holograms found on major credit cards. This light can carry millions of telephone calls over a fiber optic strand the size of a human hair. And thanks to special reflectors left on the moon by the Apollo astronauts and by Soviet probes, it can be used to measure the precise distance between the Earth and the moon to a matter of inches. This amazing light has virtually countless applications and is at the heart of the first and longest-running continuous laser show in the world, Laserium. Inside a Laserium projector, the beam from a gas laser is split into separate colors with a prism. Each beam is then directed with tiny mirrors through various paths inside the projector. The beams are then manipulated in a number of different ways. One effect is to bounce the beam off a textured reflective surface or to put something in front of the beam that will refract the light in many different directions at once, producing beautiful ethereal shapes or lumia. Unusual effects can also be produced by passing the beam through something called a diffraction grating, which multiplies the image in a number of different patterns. But when most people think of Laserium, they think of the way pictures are drawn with lasers. The secret behind this effect is you. Actually, it's the way you see things, a perceptual phenomenon known as persistence of vision. If something moves quickly enough, your vision will blur or stretch it out, making it seem solid. When a laser beam is scanned or used to draw a figure, you're really looking at a single dot moving very quickly. For instance, a dot moving back and forth will become a line. If the dot is moved back and forth and up and down at the same rate, it moves in a circular fashion. If we move the dot fast enough, you see only a solid circle. The dot's still there, retracing the same circle dozens of times per second, but it's moving so fast you can't see it. The most basic shape that a laser can scan is called a cycloid. A cycloid is a circle drawn at one rate, then that circle is itself moved in a bigger circle at another rate. Different forms result when one rate is at or near a harmonic or multiple of the other. Using computers, laser artists are able to create line drawings with height, width, and depth information. These 3D wireframe objects can then be frame animated, as in film animation, and manipulated in a variety of ways. By so doing, a convincing illusion of depth and perspective is displayed. Each Laserium show is performed by a laser artist or laserist. Because of this, no two shows are exactly alike. The laser console is actually an electronic synthesizer that generates the various signals being sent to the mirrors. Although certain functions are pre-programmed, the laserist must coordinate many visual elements and generate basic signals in real time, making each show a unique live performance. Experienced by millions of people around the world since it was first performed in 1973, Laserium is music for your eyes.
was half